Welcome to our Oilfield Water Services Field Case Study series. My name is Ross McCartney, and in this series I'll be showing you field examples of how produced water analyses can be used to benefit scale, water, well and reservoir management. For all these case studies, where they have been published, the reference for the work is given at the end of the presentation. In this presentation, you'll learn about how produced water analyses were used to identify where water was being produced from in a commingled well, the nature of this water, its composition, and its rate of production over time. The example is from the Birchfield subsea development in the UK North Sea. At the time of the study, Z3 had been producing for several years from the Bray conglomerate. The produced water was a mixture of formation water and low sulphate seawater, and the water cut had reached 99%. So the operator decided to install a tubing plug and perforate the Ryazanian sandstone to try producing from there. Unfortunately, the plug failed during well testing, and the well was then shut in for 3 years. On restarting production from the well, they achieved increased oil production due to oil accumulating near the well over time via gravity separation. But the produced water had a composition that was very different from that previously produced from the Bray conglomerate, and it was changing over time. The operator wanted to better understand where the produced water was coming from. For example, was it coming from the Ryazanian, or was it coming from the Bray conglomerate? And if it was the latter, why was the composition so different from 3 years earlier? Had the well developed a casing leak? The operator also wanted to understand what production of this new type of water meant for the scale risks to the well. So an evaluation of the produced water analyses was undertaken, and this showed that the produced water was a mixture of Bray produced water and another low salinity water. Also, it was found that these two waters were mixing in the well and not in the reservoir. It was possible to estimate the composition of the lower salinity water from the produced water analyses due to the low magnesium content of the produced water. It was concluded that the lower salinity water was formation water produced from the Ryazanian sandstone, and there was no casing leak in the well. This was because a re-evaluation of water sample compositions from the original well test 3 years earlier showed that this lower salinity water was also being produced immediately after perforation of the Ryazanian sandstone. In addition, the Ryazanian sandstone is isolated within a shale sequence, and it would be expected that formation water in this sandstone would, in part, be derived from water expelled from these shales during compaction. Such a water would be expected to have a lower salinity, an elevated sodium over chloride ratio, and a high boron content, and the low salinity water had these characteristics. The study also showed that the fraction of Ryazanian formation water in the produced water was declining over time, ultimately to very low levels, whilst the fraction of Bray conglomerate produced water was increasing. This explained the changing produced water composition that was observed, but it also helped confirm that the Ryazanian sandstone was actually a small lens of sandstone with limited size and hence oil volume. Effectively, after a while, fluids were predominantly only being produced from the Bray conglomerate again, which meant there was no need to change the scale management strategy for the well. So it was decided that the best strategy for this well was to produce it for a while, then to shut it in for a period of time whilst gravity separation occurred, and then to produce it again and repeat this cycle as long as sufficient oil was being produced each time. It is important to note that this decision had not required any well interventions, and it was based on information obtained from pre-existing produced water analyses, so no further data acquisition was required. I hope this brief presentation has given you a greater insight into the value of produced water analyses. If you require further information, please visit our website at www.oilfieldwaterservices.co.uk, where you will find our extensive publication list, which cover many field cases. You can also contact me via my email on ross@oilfieldwaterservices.co.uk. Don't forget to subscribe if you want to see more videos from us on the uses of produced water and formation water analyses in the oil industry. Thank you for your attention, and I hope that we can be of service to you soon.